As we know, Greenland is being watched very carefully because it's been responding very strongly to global warming, anthropogenic forced warming, and it's mostly in the polar amplification zone of the Arctic, which is warming much faster than the rest of the globe, which is what polar amplification means. There is a new paper that just came out on 18th January 2012, which I wanted to summarize. And starting with this National Sea Ice and Ice Data Center, we are looking here at Greenland cumulative melt days over January 1 to November 1, 2022. You can see that the last year had tremendous number of melt days, over 100 in many places, the bullet points here and over the edges here. We know that in the center melt ponds have been forming and albedo drops seriously. More energy is absorbed, then the water begins to drill into the glaciers, sometimes can go all the way to the bottom and to the base and act as a lubricant for glaciers to slide faster, and those drilled waterfalls literally are called moulins. And if you look at the Greenland melt day anomaly for April 1 to October 31, 2022, you can see that some of these regions have anomalously high melt anomaly days of over 50, which is pretty scary, and 2022, which I think now gets ranked as the 5th warmest day, with the last 8 years being, I think, the warmest ever in the last maybe instrumental records and millennia and so on and so forth. You can see that there was a huge pulse of melt area, which is bad news because end of the summer melt is critical because rebuilding during the following fall and winter depends on how much area of high albedo is available for snow accumulation and glacier growth, mass buildup of the glaciers, and so on and so forth. The paper is titled Modern Temperatures in Central North Greenland Warmest in Past Millennium, and essentially it has re-drilled some of the sites in the central north Greenland region, combined with the weather stations that are available here. There's 1, 2, 3, and has reconstructed the temperatures in the recent times to extend the older reconstruction. So this is the North Greenland temperature 2012 reconstruction, delta O18 being shown here as parts per thousand, and temperature anomalies being shown in degrees centigrade on this side, and the trends for 1000 to 1800, 1800 to 2011 are shown here, and you can see that it's been warming since the Industrial Revolution, with the current temperatures averaged, especially over 2000 to 2011, are now the warmest in the last 1000 years. Compares very well with another reconstruction that goes to called Arctic 2K. We'll look at the correlations in a minute, but corresponding to that, if you look at the temperature record with uncertainties and the melt water runoff in gigatons per year, you can see that the meltwater pulse has also become really the strongest in the 1870 to 2011 period, which is obviously which can obviously have serious consequences in terms of perturbing the Atlantic meridional overturning circulation, floods elsewhere, of course contributing to the eustatic sea level rise, and so on and so forth. So these are not small amounts that we are talking about here, right? Just to confirm how well this reconstructed data is, you can look at the correlation between the NGT 2012 and Arctic 2K point correlations here. So this is point correlations between the 20th century reanalysis version 3 field of 11-year running mean near surface temperature and the NGT 2012 11-year running mean delta O18 temperature reconstructions. So the reconstructed record has reasonably high correlation with the 20th century near surface temperature 20th century reanalysis, which is basically the blending of the data and models for the 20th century period. If you don't know what reanalysis is, you can look up my other podcasts where I explain this in much more detail. Just to confirm again, the correlation between NGT 2012 and Arctic 2K shows very high correlations everywhere, reconfirming the reliability of the NGT 2012 reconstruction. The time period calculated used for the correlation here is 1836 to 2000, and what are shown are all significant correlations. If you want to see where the power spectral density or what are the intrinsic time scales that are there in the reconstructed time series, you can look at time periods in years going from 200 to 5, and you are looking at power spectral density in degrees centigrade squared year, and you can see that NG 2012 has a range and has a spectral peak here, which is actually very different than the Arctic 2K, which seems to have basically not much signal in, let's say, the 50-year to about 10-year time scale for whatever reason, which I will not get into. But if you look at the squared coherence between NGT 2012 versus Arctic 2K, you expect it to drop off where they don't agree in terms of power spectral density. But if you look at NGT 2012 versus 20th century reanalysis, that coherence is very high, and they both drop off in the decadal and sub-decadal time periods. So keep this in mind as well. And you can look also at the probability density of the pre-industrial distribution of anomalies versus the range of NGT 2012 anomalies here. So in terms of parts per thousand, this is a delta 18 reconstruction, and you can see that the pre-industrial distribution of PDF is basically almost Gaussian, around near zero or slightly negative. But if you look at the 2001 to 2011 average, it's clearly way out of the tail of the entire period, over 1000 to 1800. So we have jumped way beyond the internal variability that would have produced this distribution in the pre-industrial period, and presumably you can attribute it to the human activities and the related global warming. The pre-industrial reconstruction of the meltwater runoff is done using some statistical approach, and an available meltwater anomaly data set is used to look at the colors here for the NGT 2012 period, 1871 to 2012. And again, you can see that the average of 2001 to 2011 has jumped clearly out of all the meltwater distributions that happened for the temperature anomalies. Presumably you can assume that's natural variability, so we are way beyond natural variability now in the period for 2001 to 2011, again in gigatons per year. So it seems like the results are fairly robust and validated against other products. The last paragraph concludes, our findings demonstrate that recent temperatures in central and north Greenland are higher than in the past 1,000 years, and thus demonstrate that global warming is now also detectable in one of the most remote regions in the world. So Greenland glaciers are very high, a couple of kilometers, very isolated, and yet they are logging some of these warmest temperatures in 1,000 years. Likewise, meltwater runoff observed today is probably unprecedented over the past millennium. As warming supports an increased frequency of more widespread summer melt events, reaching in some regions, some occasions also central and north Greenland, firn properties such as permeability and meltwater retention may change, comparable to firn changes observed in warmer and lower elevation areas. Combined with the findings that temperatures in central and north Greenland and meltwater runoff in the ablation zone are already unprecedented compared to the past millennium. An increasing mass loss of the ice sheet is expected under further global warming. So firn is, you have stages of snow, firn, hoar, glacier, compressed snow, becoming glacier, and so on. So you can look up the definitions in my other podcasts as well. But this is obviously a warning because now we have the ablation zone, which is where the glacier loss is greater than accumulation. So these are not good news in terms of the increased ablation and areas of melt and meltwater runoff and so on. Okay, so brief introduction. It's a nice short paper. You can read up more if you're interested in details, and obviously also comes with very good list of references that you can follow up on. Okay.